Hello everyone, welcome to UmojaHack 2021. My name is Darius Moruri. I'm a data scientist at Zindi. Today I'll be taking you through the UmojaHack Beginner Challenge. So we can go ahead and start. So the first thing you're supposed to do is navigate to the Zindi website, and then you can click on the compete page, and then navigate to the hackathons page. For this UmojaHack, we have three kinds of competitions, depending on your skill set and your data science experience. We have a beginner challenge, an intermediate challenge, and then an advanced challenge. So today we'll be going through the financial resilience challenge. So you can click on it. And then this is a private hackathon open to undergraduate and postgraduate students from African universities. So for you to join, you must have a secret code. You can go ahead and click on the join hackathon. So before we join, you can provide your username and your password. Yeah. So after joining, you'll have access to the data. The data will contain a training set, a test set, a sample submission file, and a starter notebook, both in R and Python. So you can also go through these details on practicing on how to make a submission to Zindi. You can also check the rules on teams and collaboration, on the datasets and packages we are supposed to use for this hackathon. So specifically for this hackathon, you'll only use the provided datasets. And then for the packages, they have to be public to everyone. The evaluation metric that we use to gauge the performance of our models is the area under curve. So for each individual, you have to provide a probability of how likely that individual is to be financially resilient or not. So it should include an ID and a target. And then you provide raw probabilities from the model. You have to know that the probability should not be, you should not set a threshold on the probabilities or round your probabilities. They have to be raw from the models. You can also go ahead and check the prices. For you to win, you must be present at the UmojaHack Africa event. You must currently be enrolled as a student at an African university. So the first prize is $700 for the first individual will win, and then that university will also win $1,500. Second place $400, and third place is $300. You can also go ahead and check the timeline of the hackathon. So we'll be using the free resources of Google, Colab. So you can go ahead and access that. And then you can upload the starter notebook that you downloaded. Also, you have to upload the data files. So you can go here and then upload the training set, the test set, the sample submission file. So just go here and click this, and then you can upload this. So because this is a starter notebook, we won't cover much, but we will cover loading the data, doing a simple EDA, data preprocessing, creating a simple model, and then I'll show you how to make a submission to Zindi. And also you will get some tips on how to improve your score in case you are stuck. So these are the libraries that we'll be using to create a simple machine learning pipeline. Pandas and NumPy will be used it for data manipulation. And then for exploratory data analysis, we use Matplotlib and Seaborn. To check the accuracy or the performance of a model, we'll use the sklearn library. And to train our model, we use LGBM and the random forest classifier so that we can compare the two and see which performs better. So you can go ahead and then load the files. So the training set is what we use to train our model, and the test set is what we make our predictions on. The sample submission guides us on how we should create a submission file to load to Zindi so that we can get a score. You have also been provided with a variable definitions file to show you what the features, all the column names mean. So we can go ahead and check the first 5 rows of the train dataset. So these are the columns. We have ID, country, regions, population, age, and then questions from 1 to question 27. Also, we have a column on whether an individual owns a mobile phone or not. So what we are trying to predict here is the target. So this target shows you whether an individual is financially resilient or not. So 0 means that an individual is not financially resilient, and 1 means that an individual is financially resilient. So by just looking at this data, we can see that it has categorical variables that we need to change into numerical before we train our model. We can also see that there are missing values, so we have to do something about that. We can also go ahead and check the test dataset. So the main difference between the training dataset and the test dataset is that the test dataset does not have a target variable. That's what we are trying to predict. And then this is how our sample summation should look like. It should contain an ID, column, and a target. So the target has to be in terms of probabilities. Don't forget that when trying to make predictions. So we saw that these column names of Q1, Q2, Q3, you can get the explanations and definitions down here. We can see that the Q1 means that shows us whether an individual has an ATM card or a debit card. You can go on and check the rest. We can also check the size of the data that we have. For the training dataset, we have around 104,000 observations, and we are trying to make predictions on the test, which has 44,000 observations. So from above, we saw that there were missing values, and so we can check what percentages for each column that are missing. So we can see from here that the Q7 column has the highest percentage of missing values, which is 80%, followed by question 23. So you can go here, this question 7 and question 23. Question 7, use of mobile or internet to make payments or send money. So most individuals did not provide this information. So you have to take care of that when building your model. We can also go ahead and check the missing values on the test dataset. You can see from here that it mirrors the trained dataset. Like the Q7 has 80% missing values, and the test dataset has 80.3, so they're almost similar. We can also check whether there are duplicates in the data. Lucky enough for us, there are no duplicates. And then also we can go ahead and check the distribution of the target variable. From here, we can see that the majority of the individuals are financially resilient, and those who are not financially resilient are a bit misrepresented. So we can see that this data is fairly balanced. There's just a slight imbalance between the classes, with one being having the majority and 0 the minority. So you can go also ahead and explore the column features, these columns here. So you can also check the distribution of maybe Q1, Q2, Q3, and then you can draw insights from that can guide you on how best to pre-process your data. So if we check the Q1 distribution, we can see that the majority of individuals do not have ATM or debit cards, followed by those who have, and then others decided not to answer or they didn't know. So from this, we get some insights on how best to build a model. So when it comes to machine learning, whenever you pre-process data, whatever you do on the training data set, you have to also do it on the test data set. So instead of doing it separately, you can opt to do it at a go. So you can combine the data together and then do the process, and then after that you can split the data back to test and train. So we can decide to combine the data here. After combining the data, we can check the column names and the column data types. So from the variable definitions we saw that that the Q1 to Q27, Q28, these are categorical variables, but they have been represented as integers and floats. So these has to be changed to categorical data type. So you can go ahead and do that. You can confirm that down here, categorical variables have been changed successfully to categorical data type, and integer and float have been done successfully. So you can decide to explore the data further. You can also check the unique variables on each column. For example, the country feature has around 144 unique countries. For regions, we have 8, and then for the questions that the individuals answered contained 4 options each. So the next step is, before we build our model, we have to take care of the missing values. So depending on the data you have, you can opt to fill in the missing values using a mean, max, minimum. For categorical variables, you can opt to use the mod, or you can also do a little bit a complex kind of filling, and then you can use the sklearn simple imputer. Another option is you can opt to fill in the missing values using a large number that is out of the norm with the features. So in this case, I decided to fill in using 9,999. 19,099. For the categorical features, I decided to fill them in using the mod. You can see here, that's what we did. And then, as we remember, some columns are categorical, so we have to convert them to numerical before we train our model. So you can opt to use one-hot encoding, label encoding, or you can use target encoding to do feature engineering. So before doing encoding, we can see that the number of columns are just 36. And after doing encoding, one hot encoding, you can see that the columns have increased to 276. So you have to come up with ways to maybe reduce the number of columns, or you can use feature importance, or you can use PCA LDA to try and reduce the number of columns. So after doing a pre-processing, we can go back and then separate the training dataset and the test dataset from the combined dataset. After separating those, now we are ready to train our model. So before we train our model, we have to split the data into training and then validation. So I opted to use 30% of the data to test the performance of our model. So in this case, I used the random forest classifier. Then I trained it on the X train and the Y train. And then I made predictions. So don't forget to use the predict probability, because the area under curve is our metric to measure the performance of a model. So after that, we can see after training our model and predicting on the test dataset, you can see that we get an area under curve of around 0.76. We can also go ahead and print the classification report, which can tell you the accuracy of the model. In this case, it's 70%. And then the precision, the recall, the F1 score, you can also check that. So with the data science and machine learning, usually it's a try and error kind of iteration. You have to try different models, different parameters, different feature engineering for you to get the optimal solution. For this case, I decided to use a random forest classifier and LGBM classifier to check which one gives a better score. So when comparing the LGBM classifier with the random forest classifier, the LGBM classifier outscored the random forest classifier by around 0.02 AC. So if you want to get more information on the area under curve, you can go ahead and check it out. So area under curve represents the probability that a random positive example is positioned right to the negative example. So you can go ahead and read all this so that you can understand how the area under curve works. After training our model, now we are ready to make predictions, the data set that we were provided by Zindi. So you can go ahead and make predictions. Don't forget to use the predict probabilities, because area under curve is scored using probabilities. So you can go ahead and use the sample submission file and just change the target column. So after predict on the test dataset, we can see the distribution of our predictions. The majority are those individuals who are financially resilient, and then the minority are those who are not financially resilient. After that, you can create a submission file. So you can use the CSV function, pandas function, to create a file. Don't forget to use this index to false because if you don't use it and then you upload the data to Zindi, you'll get an error, a submission error. So don't forget that. So after creating the file, you will go ahead and check it here, and then you can download it and submit it to Zindi. Some tips on how to improve your models in case you're stuck. You can do some domain knowledge sourcing. You can try to understand how banks work, what influences an individual to be financially resilient or not. Also, because we have a lot of categorical variables, you can also decide to group the categorical variables. For example, you could decide like to combine Q1 and Q2 to see whether that field engineering will improve your model performance. You can also check out these more tips. If you have any questions, feel free to post them on the discussion on Zindi, and then we can assist one another on the Zindi discussions board. That's it from me. I wish you luck and have fun. And don't forget that in Zindi, there is no losing, there's only learning and winning. Good luck to you all.